All right, so in chapter 5, talking about statistics and probability. And for IB especially, this chapter is so important for the entire IB exam process, largely because you will be really encouraged to use this in your IA when you can, if your IA involves some sort of data collection or some sort of study. Um, so this is really big or can be really big for your IA if this is the avenue that you choose to go down, and that's something that you'll explore more in year 2. But in this first chapter, we're going to talk more about sampling methods and how we actually get our data. So we have two categories that we can put data in, and that's either qualitative or quantitative. And if data is qualitative, then it can be described in words, right? And that might be something like, how are you feeling today? Or what hometown do you live in, right? Where are you born? Things like that. So we'll say hometown. Right, so these are described in words. What's your favorite color? What college did you go to? Things like that. And this can still be just as important data. The other type of data that we have is quantitative data, and that is something that is numerical, right? Quantity. It's right in the name. So this is numerical data, right? So this might be things like your age, your salary, how long your commute to work is, things like that. So the big difference here is qualitative words. Think about the word quality. And then quantitative numerical, think about the word quantity. And then, well, quantitative data we can actually describe even further. We can categorize it even farther and as discrete or continuous. So discrete data is countable. It can be counted. So again, things like your age, perhaps, if we're talking in terms of years, maybe the number of wins by a particular team, the number of siblings that you have, right? Things you can count. Versus continuous data is data that can be measured. So things like your height, weight, even something actually like price, even though price we usually think about as discrete because you kind of count cents. We typically actually think about price um, as a continuous quantitative, data. So the trick for telling these two apart is this. If something is discrete, then usually we're dealing with something in the natural numbers, the counting numbers. And if we were actually just to describe some change in um, this number of discrete data, we would use the word fewer, right? We might say that one team has fewer wins than another, or I have fewer siblings than someone else. In the case of continuous data, we're usually dealing with values spanning the entire real numbers, and we would usually use the word less to describe a difference between the two, right? So I would say maybe I'm less tall than somebody else, or this is less expensive than if I had bought it at another store, or I weigh less than someone else. So it's the difference. This is really the difference between fewer and less. You know, where it would be grammatically appropriate to use fewer versus grammatically appropriate to use less. It's the difference between counting something and measuring something. Well, if we want to talk about collecting our data or data, however you choose to pronounce it, we need to talk about different ways we can actually use this data. And usually it's not either feasible or viable to sample the entire population and look at the entire population when you're collecting data. So when we talk about the population consists of every member of a group being studied. This doesn't necessarily mean humans, right? So this could be something like Americans, right? We could sample all of Americans. We could sample all teenagers, but it doesn't have to be just people. We could sample all computers. We could say we could look at the population of calculators being manufactured, right? They do not have to be people necessarily. So then a sample is any subset of that population. And we're using that population to draw conclusions. Sorry, we're using that sample to draw conclusions about the population. So maybe if I want to consider a population here, and we'll stick with the humans for now, but it doesn't have to be humans, right? So we could look at the population of US adults. Well, if I took a sample of US adults, right, this would be my population here, so maybe I'll write that in. This is my population. Then my sample would be to take just 1,000 adults. This would be my sample. It's some representative subset of the population, and I'm going to use that population to draw conclusions. Sorry, I'm going to use that sample to draw conclusions about the greater population. Something that is a less good, a worse sample of US adults is if I said just adults age 18 to 25. And this doesn't really work as well because it's not a representative sample, right? This is not something that accurately represents the entire population. But if we wanted to, we could look at this as its own population. Maybe I wanted to talk about adults 18 to 25. And to do that, I could maybe take 500 of them. And that would be a good sample. So I want to make sure my sample is representative of the population. Well, to do that, there are 5 considerations that I need to look at. And the first one is the target population. So going exactly off of what we just talked about, I want to look at the target population. And as you might expect, this is just the group of things I'm taking the sample from. So I'll say the population from which the sample is taken. The next thing you want to consider is the sampling frame. And the sampling frame is the list of members of the population that you could possibly choose for your sample. So I'll say the list of members of, I'm just going to abbreviate here, of the population from which you choose to build a sample. And I'll kind of explain how these all tie together in a minute because they're going to sound very repetitive and kind of overlap with each other. So the next thing I want to talk about is the sampling unit. And the sampling unit is just an individual member of the sampling frame. So I'll say an individual, or I guess if I'm talking about set theory, it'd be an element, but with samples, we tend to talk about members of the sampling frame. And then we have the sampling variable. So that's the actual condition being studied or investigated. So we'll say the variable being studied or investigated. Right, there's some sort of a characteristic. And then the sampling values we can kind of think about as the domain of the sampling variable. So this is just the set of the possible values that the sampling variable can take. In a lot of ways, as I said, this kind of almost looks and works like domain. So what does this all mean? How do I put it all together? Well, if we're talking about actually designing a sample, then I'm going to say, if I want to investigate this target population, then I'm going to say from the sampling frame, right? I'm examining this sampling frame of all these members. And from that sampling frame, I'm going to study some number of individual units and examine this variable, which can take on these values. And this will make much more sense when we talk through an example, which I'm going to do right now. So the example here, you want to conduct a survey to estimate the number of IB courses taken by students at Prout. I want to define the target population, sampling frame, unit, variable, and values. So my target population is just going to be the Prout student body, right? I want to look at all of the students at Prout. Maybe if I wanted to be more specific, I could look at just specifically IB students at Prout. But my sampling frame, right, if I'm looking at my population, it's just the set of students at Prout. If I wanted to talk about the elements in those set, my sampling frame, that would be a roster of all the students. Right, I want an actual list of all the members of the population that I could potentially select for my study. Well, one unit from that frame would be a single Prout student. What am I trying to look at? What am I looking at when I talk about that one student? I'm looking at the number of IB classes they take. And then if I were to ask you, is this discrete or continuous? Well, this is a discrete piece of quantitative data because it can be counted. I can count the number of IB classes that you take, which means my sampling value could be any number in the natural numbers. Right, this works a lot like domain, like I said before. This is a lot like domain. You don't have to write it that way. I think it's easier to, but our textbook tends to just list them. I would prefer the set notation just because we've learned it. It's a shorthand. It tends to make things a little bit easier. So just to wrap up, what does this all mean? Well, again, if I walk through this, right, actually I'll use my pointer here. I want to conduct a survey to estimate the number of IB courses taken by students at Prout. So I'm going to study the Prout student body, and in order to do that, I need to consider from my roster of Prout students, I'm going to take so many of them, right? So in order to study the Prout student body, I'm going to take my sample from the list of students at Prout, and then I'm going to ask each individual student, that's my unit, how many IB classes they take, and the number, or their response, their possible responses are going to fall in the set of natural numbers because they can count the number of classes they have, right? You can't take -1 courses, and you can't take 1.245 courses. So that's kind of how you're connecting these, is kind of walking through each step of designing your survey to say, well, I'm studying X thing. In order to do that, here's how I could possibly make my sample. From each unit in that sample, I'm going to ask them about this measurable thing and the values of their responses, right? The responses they will give are going to look somewhat like this. And that's how we would really start to consider designing our sample.